Alright guys, welcome back to our class. Today we're going to do a little bit more on buttons, and then once we're done with that, then the next lesson we can get started with computer coding. But we got to go a little bit further with buttons before we do that. Alright, so real quick, go ahead and look on the whiteboard here. I'm going to do a quick review. So let's draw the schematic for how to get the light to turn on when we press the button. Okay, so here's the light. We have our button here. It goes like this, okay? And like this. Alright, and just to recap, so whenever we press the button, what happens is these two legs here become connected to these two legs here. So when we don't press the button, there's a gap here. No electricity can flow, so that's going to be an open circuit. And then when we press the button, these two become connected, and then we have a closed circuit, and the light turns on. Okay? All right, so this is the circuit we've built before. Now, if we draw a table here, so we'll say press, let's change this to button, and then over here is LED, right? So when we press LED, when we press the button, the LED is on, and when we don't press, LED is off. Alright, so if you remember back when we first started this class, I talked about the ability to fix things. That's one of the life skills that I wanted to teach you. And so what we're going to do is we're going to do something like that today. We're going to learn how to fix something. Now, sometimes things aren't necessarily broken. Like for example, this circuit right here, if we design it this way, it's not necessarily broken, but we still want to fix it in the sense that it's not doing what we want it to do. Alright, so let me explain that a little bit more. So we're going to fix this circuit that we have here by making it do this. So I'm going to redraw our table here. I want it to do the opposite. So when I press, it's going to go off, okay? And when I don't press, it's going to be on. So this is number one. We need a number two. So what we're doing here is we're reversing it. We're making it opposite. And this happens all the time in engineering, where you have something working one way, but because of something else in the design, you need to reverse it. And I'll just teach you a little keyword here, or vocab word. This is called reversing the polarity. Okay? So whenever you take like a circuit and you make it opposite, you're reversing the polarity. Polarity just means that it's like there's plus and minus, there's left and right. It's just the opposite. They're high and low. Whenever things have things like that, it has a polarity. Okay, so we want to reverse the polarity. Now, how are we going to do that? How are we going to change the circuit? So let's first build circuit number one. Okay, so we got here, we have the power. And then let's make sure I get my components here. We need a resistor, and look, I didn't specify what resistor, so let's use the 470 ohm resistor. Remember, that's the one without the red stripe, so it's going to be this one here. And we have to make sure that one side's connected to the red 5V and the other side is on the new connection, and then we get our light. Let me grab a light here. Long leg. Just to be clear, let's update our schematic here. That should be the plus and that's the minus. So the long leg connects to the resistor and the short leg on a new row. And then we just do the, need a button. Top row of the button goes to there, and then the bottom leg is, bottom row of the button's down here, so let's connect that to G and D. Alright, so we've done this a bunch of times. It's just good to always refresh so that we get really accustomed to this. We give it some power and hopefully that works. Excellent. Okay, so this matches our number 1 circuit, and when we press it, LED is on. When we don't press, or we let go, the LED is off. Okay, so now that we have that, how are we going to fix this so that 1 becomes 2? For when we don't press, the LED is off. All right, so we got to really think through this. All right, so now we're going to go through what we call the design process, which is the planning part before we actually build the solution. So let's think. When we don't press, we actually want a closed circuit, right? Because when we don't press, we want the LED to be on. So we have to think, well, the LED will only be on if there is a closed circuit. So why don't we do this part first? So I'm going to call this part A. So let's do part A. So if I was just going to do make a circuit where the LED is on when I don't press, then let's just do that. We've done this a million times, one of the first circuits that we built. Okay, so this circuit right here is always on. Okay, now that's fine. And if there's no button here, so it's just like if you don't press the button, it's just like the same thing as if there's no button. So if you don't press it, it's on. Now how do we do this part? Part B. So that one's the tricky part here, right? So how do we get it to turn off when we press the button? Where do we put the button in this case? All right, so now we got to use our brains. Okay, so how do you turn the LED off? So I'm going to step through this. So number 1, so this is how my brain thinks, and so I want you to kind of just follow my brain, because this is how it's good practice so that you can figure things out in the future on your own. All right, so the first thing that's in my brain is, okay, so how do I turn a LED off? Okay, well, one way to turn the LED off is create an open circuit. Okay, so I need to make an open circuit and it'll turn the LED off. Now if I remember, I'm going to draw my button back here. Now the way that this works is that when I press the button, so there's two lines there. When I press the button, the top becomes connected to the bottom. So it's kind of weird because when I press it, I want the LED to be off. So another way to say that, going back to number 1 here, is when I press it, I need an open circuit. Now, what an open circuit usually works, how it usually works is like, okay, I'm going to draw right here. Okay, if we have, I'm just going to draw a simple circuit with no resistor. So this is a closed circuit. If I make an open circuit, what it usually means is I break the circuit. So I go like this, and I make an opening. Now that's open. So to make an open circuit, I need to make an opening in the circuit. But check out the way the button works. The button only becomes open, or there's only a break in the circuit if I don't press the button. But if I press the button, what happens? It actually connects to the top and the bottom here. So when I press the button, it makes a closed circuit, like it makes that connection, which is why number 1 up here works. But number 2, the question is, when I press the button, I want it to be off. Or in other words, when I press the button, I want an open circuit. So I see it's opposite from what I want it to do. Now, maybe I'm thinking, is there maybe a different button that when I press it, it becomes open circuit, and when I let go, it becomes closed circuit? If I had that, that would fix it, right? If my button here just behaved opposite of this button here, then it would work. But unfortunately, I don't have that. And so that happens in real life engineering too, right? Is that, that's one solution. If I find a button, if I use a button that's opposite from that one, that would work. But unfortunately, that's not possible. I have to use what I have here. Okay, so what that's telling me is that this, making an open circuit thing, probably not going to work. So, and let me erase this, make myself some new room here. So how else can I turn the LED off? Okay, well, there's another way that I can turn the LED off, is by giving 0 volts to the LED. What do I mean by 0 volts? 0 volts is the same as no power. All right? So all this means right here is that if my LED has no power, then it won't turn on. Okay. So can I give my LED no power but still have a closed circuit? That's kind of the other question. The answer is yes. Yes, you can. Okay. So here's how we're going to do this. I want you to look at this LED here. Let me draw my plus and minus. Okay. And I'm going to get rid of this for now. So the voltage between the plus and the minus, that's the amount of power that the LED is getting. And if I said if there's no volts or zero volts between to the LED, then it will be off. Now, how do I know how many volts are on the LED? I go the plus voltage minus the minus voltage. Okay, what I mean by that is that, let's say at the plus I had 3 volts, and at the minus I had 0 volts, then the voltage on the LED is 3 minus 0 equals 3. Okay? Now let's say if I had 2 volts here on the plus and 1 volt here, what do I get? 2 minus 1 equals 1. All right. So, but what if I had this? What if the plus and the minus were the same? So for example, if I had 2 volts here and the minus is also 2 volts, what do I get? Equals 0. And then what does it say here? Giving 0 volts to the LED. We'll turn it off. So another way to think of this, guys, if I make the plus and the minus the same voltage, the light should turn off. All right. Hopefully you guys are still following here. So here's what we're going to try. Okay. And I'm going to erase this. I need some room. Okay. Take my button, connect here, and connect here. So let's think about what's going to happen here. If I don't press the button, the top leg and minus leg, they're not connected, so it's going to be like their button's not even there. It's just going to be on. So this part of the circuit will work here. But what happens when I do press it? When I do press it, what happens is that this becomes connected with this. Now this is also connected to here, and this is also connected to here. So what does that mean? That means the plus and the minus, they're going to be the same. And if plus and minus is the same, we get 0 volts. All right? So this is just theory here. So that's kind of how I came up with the solution. Let's see if that actually works. Okay? So I'm going to take this circuit apart from number 1 and then change it to 2. So as always, start with the plus, and then I'm going to follow along. So I got this here, my resistor is good, then my light, and then my minus currently goes through this button, but I don't want to do that. So I'm going to take that out. I'm also going to take this out, because right now what I need is the minus of the power goes directly to the minus of the light. So that means I go like this. There. So right now I don't press the button and it's on. Well, actually my button's not even connected. So let's just make sure I connect my button. Now this is a little bit tricky here. The top leg of my button also goes to the plus of the light. And then the minus of the light goes to the bottom of the button. All right, I need some more room here, so I'm actually going to take this apart. So let's go like this. Okay, let's make some room. So the plus leg is here and the minus is there. Give me some more room, right? I'm going to move this over. Okay. So let's do this. The plus of the light and the top leg of the button are on the same row. See if I can get this going. My legs have to be squished in a little bit. There we go. There. So the plus of the light is connected to the top row of the button, and that same row is also connected to the resistor. And then the minus of the light is connected to the bottom row. And then now let's put in our GND, or our minus of the battery. So when I put it in, it should turn on. Excellent. All right, and then now, if I press the button, it should turn off. Let's try it. Press. There you go. Let go, it's on. Press, off. Let goes on. Press. All right, so we got it to work. Now, there's one thing I want to mention here before we move on. When I press the button, so going back to the whiteboard here, when I press the button, there's a connection from here to here. So here's what happens to the electricity. It starts from here. It's going to go through the resistor. And then look, it can either go down this way or go down this way. But what's going to happen, because there's this path here created by this button, all the electricity is going to flow like this. Okay? Now you may be asking, like, so why does it do that? Well, one way to think about it is that electricity is kind of lazy. So what it does is that it goes through the path of least resistance. So if we look at it, the LED here, if it wanted to go through this path, it would have to actually go through an LED, which has some built-in resistance, and it's just more work for the electricity. But over here, there's a direct connection here from up here to down here through the button. So this is an easier path, so it just goes through that way. And that's another way to think about it as to why the LED doesn't turn on when you press. Because you're giving another path, and then the electricity is going through the path of least resistance. Okay? All right, so that's why that works. Now, I also want to point out this resistor here. It's very important that we have this resistor, otherwise this number 2 circuit's very dangerous. Okay, and here's why. So when we press the button, you have electricity going through like this. And that's, remember, we use 470 ohm. So when we press it, the current, let's calculate the current. V equals IR, if we remember Ohm's law. And so another way to say that is I, which is the current, equals V over R. So when there's 470 ohms here, and remember we were using 5V here for the power from the Arduino. So in this situation, it equals 5 volts divided by 470 ohms, which equals, get my calculator here, okay, let's see, it's 5 divided by 470, you might be doing it over there, it becomes 0.01 amps, okay, which is the same as 10 milliamp. Okay, now imagine we don't have this resistor. Imagine, let's break this here, and we have that. So what's going to happen? Well, So what happens here is that, let's calculate. I equals V over R. We still have 5 volts of power. What's R? Well, there's no R there anymore. There's no resistance, so it's 0. All right, you may have not learned this yet in math, but if you take something and divide it by 0, it actually equals infinity. In other words, a really, really big number. So what happens if you have a lot of current going through the circuit like this, or an infinite amount of current? That is how electrical fires start. So what's going to happen is this circuit will keep drawing current, like pulling current from the 5V until there's no more to go, until the Arduino here gets overloaded. You might see some smoke come out here or something like that. So that's why that's not going to be good. All right. So another way to say this is called a short circuit. All right. A short circuit is when you have a path like this from plus to minus and there's no resistor. Short circuit equals bad. Okay, so we do not want to do that. So guys, we do need to be careful when we make this circuit here. We want to make sure that we have this resistor inside there. Okay, so that is the lesson for today, where we build this circuit with reversing the polarity. So what we're going to do when we meet again, we'll talk a little bit about this, and I'm going to give a couple more button exercises when we meet again, and then after that we're going to go into some computer coding so that we can make our light do some stuff, turn off and on even without pressing the button. But we'll get into that next time. All right, we'll catch up later.